Here goes circuit 6. It looks really kind of nasty. We have a 12-volt battery. The current splits between these two branches. In the bottom branch, it goes through two resistors, and then for the first time, this top branch splits a second time, going through two resistors before it comes back together to go through a last resistor, and then the original two splits come back to become one. I think this particular circuit looks a little, easier to work with if we rotate it 90 degrees. In this particular circuit, we are just going to find the voltage drop across the 3 ohm resistor, which is this one here. And so I'm just going to kind of work as far as I need to get to that answer. So to get there, I need to try to get a more simplified circuit. So I'm going to combine first these two resistors that are in parallel. So that would result in a circuit that has my 12-volt resistor. It's then going to break off, go through this R equivalent that I'm going to find in a moment. It'll then go through that 4 ohm resistor that's still there. Before it comes back together, the other side of the branch has the 3 ohm resistor and the 5 ohm resistor. Again, we're going to be interested in finding the voltage across at 3 ohm. By finishing the circuit, those go through, the wire comes back and returns back to the battery. Let's make that look a little easier. So then if I want my equivalent resistance for this, those two are in parallel. So 1 over the equivalent resistance is 1 over 12 ohms plus 1 over 6 ohms, which would be like this is 2 over 12 instead. And so we have 3 over 12 ohms, 1 over R equivalent, and so R equivalent would be equal to 4 ohms when we flip that ratio of 3 over 12 to be 12 over 3. And so this equivalent resistance is 4 ohms. All right, so then I'm not going to be able to find my voltage drop yet. So I need to go and find another equivalent circuit. I'm going to do two things at once. I'm going to find the equivalent resistance of the parallel branch on the left and the equivalent resistance of the parallel branch on the right. This will result in a circuit that has my 12 volts and going through an R equivalent from the left and an R equivalent from the right, which those two will then come back together and go through the battery. For each branch, let's do a different, the R equivalent on the left, both of those are in series, so the 3 ohms plus the 5 ohms is 8 ohms. So this is 8 ohms on the inner branch. The equivalent resistance on the right will be the 4 ohms plus 4 ohms, which is 8 ohms. And so that would be our 8 ohms here. And then we have to go one more step. So if we now just have these two resistors that are in parallel, and so I can go to my most simple circuit with an R equivalent and my 12 volt battery. This R equivalent we'll find by 1 over R equivalent equals 1 over 8 ohms plus 1 over 8 ohms, which is 2 over 8 ohms. And so the R equivalent is 4 ohms. That means then the current out of the battery will be the voltage over the resistance, which is 12 volts divided by 4 ohms, which is 3 amps. We then know that through the two branches up here, So through this branch and through the other branch, since the resistance of the two are the same, that the current that came out of the battery will get split evenly between the two of them. So let's zoom out so I can get the numbering correct. So then that means that the current through the 3 ohm resistor is going to be half of the current coming out of the battery. So that would be 1.5 ohms, and that would be the same as the current coming out of the 5 ohm resistor and the current out of the 4 ohm resistor as well. Okay, but really this is as far as we need, because we now know the current that's going through the 3 ohm resistor, and we know its resistance is 3 ohms. And so if we want the voltage drop for the 3 ohm resistor, that's going to be the current times the resistance. So the voltage drop is going to be 1.5 amps times 3 ohms. So the voltage drop from the 3 ohm is 4.5 volts. And then that's it. That's all you need to do to answer this particular problem, which just wanted the voltage drop across the 3 ohm resistor. But you can totally take this opportunity to go and find the current through the 12 ohm resistor and the 6 ohm resistor as well. Really? Oh. Sorry. As well as the voltage drops across the rest of the resistors. So I'll leave that to you for an exercise to do if you're so inclined. And maybe in the, what's the word as well? In the lecture slides that are available as PDFs, I'll include those additional values so that you can check if you want to.